Hubhopper Originals.
To start your podcast for free, log on to studio.hubhopper.com.
Hello, everyone, and welcome back to Indian Genes. We have a great episode coming up for you today, and I can assure you that this is something that's going to be very inspirational for all of us listening. It was for me while I was doing this episode. We talk more here about the future of space exploration. We have two very young minds that are currently involved in the Perseverance mission on Mars. One is involved with the MASTCAM-Z instrument on board, and the other with the MOXIE instrument on board. So this is a back-to-back episode, and it's something that you're definitely going to have fun listening to. Our first guest today is Mohini Jodhpurkar, and she is a first-year PhD student in Dr. Jim Bell's laboratory at Arizona State University. There she serves as a student collaborator on the Perseverance Rover's science team, specifically working on the MASTCAM-Z instrument. She has worked on other Martian and lunar projects as well besides this, including revamping all the old Apollo mission maps with newer and high-resolution imagery. When Mohini is not doing research, she loves to read, write, and make music. Our second guest is Piyush Khopkar, originally from Ujjain in Madhya Pradesh. He did his Bachelor of Engineering from the Mahakal Institute of Technology in Ujjain and a Master of Science in Electrical Engineering from the University of Missouri-Columbia. He is very passionate about space exploration and is part of the MOXIE and Mars 2020 science team. He's also an active member of the NASA JPL Solar System Ambassadors Program. So it's going to be real fun listening to the future of what space exploration is going to be like through these two young minds. And one of them will talk to us about the MASTCAM-Z instrument and her background and how she got into it, while the other will give us a little bit more insight into MOXIE, what exactly MOXIE is doing on board the Perseverance on Mars. So Indian Genes now very proudly presents this back-to-back episode with Mohini and Piyush. So Mohini, a very big welcome to you from everyone here at Indian Genes. It's an absolute pleasure to be talking to you, and we have spoken to a lot of people now connected to Mars, but speaking to you from a different perspective, and that of a student and what you actually do. So before we get into any of that, why didn't you just let us know a little bit about yourself, give us a little bit of background so people listening to you can understand where you're coming from?
All right. Well, hi everyone. I'm Mohini, and I'm a student at Arizona State University. I'm a first-year PhD student there. In that capacity, one of my roles is I'm on the MASTCAM-Z team, and by virtue of that, on the March 2020 science team overall. That's a very exciting opportunity for me because actually, ever since I was little, I've been very interested in Star Trek as a show, and my dream job has kind of been to be the science officer on board the Enterprise, and I can't do that obviously because we're not there yet, but this kind of feels the closest to that I can get right now. So I really love it a lot.
Tell us about this interest that you said you had in space or in space exploration. Did this start while you were in college, and how did you build towards it, or what did you do consciously to work on this particular aspect of your interest?
Yeah, so it's actually really funny. I've been interested in space for a long time actually. My parents like to tell the story that by the time I was 2 years old, I was already saying all the planets in order. And I had this one space book that I would just like flip through it and look at all the pictures of the planets. But for a long time, I didn't actually think I could have a career in space because I thought I had to be good at physics. I was kind of approaching it from the astronomy perspective. I didn't realize that planetary geology was such a big discipline. sort of until college, actually, because I through the process of high school, I realized that I liked earth science the most of all the sciences. So I had kind of gone into college with the idea of, studying geology. But while I was at college, I was exposed to a class about planetary geology, and I was just blown away. I thought that was such a cool concept of applying the principles of earth science to other planets. And especially Mars is the most exciting because we have so much data from there comparatively that you can do a lot of things that are very similar to the way geology happens on Earth. So like like all the analyses and like trying to understand the planet is a lot more possible on Mars than most of the other planetary bodies. In 2017, I had an internship at the USGS Astrogeology Center, which is in Flagstaff, Arizona. And that was really, I spent the summer there and I was studying a specific formation on Mars through that. And that was what really got me into the research track and what really made me want to actually pursue this. And I actually took a gap year between undergrad and graduate school, and I actually worked at that same USGS Astrogeology Center. I was lucky that I had built connections when I was there for my internship, and I was able to work there for a year. And that was really a rewarding experience too. But now I'm here for school, and obviously this virtual setting is different, but I've still been enjoying it a lot. So when I went into undergrad, I actually thought I wanted to be an earth science teacher. So my plan was to my school had a 5-year program where you could get a master's in education, and I was going to do that, just study for 5 years straight through. But because of my internship, and then in the subsequent year, I also had another internship at the Air and Space Museum in DC. And both of those experiences really told me that research is what I mean. I still have a passion for teaching. I do love children, and like I like this idea of science communication and talking to explaining difficult concepts to people in ways that they can understand. I just was very drawn by the idea of actually being able to be studying aspects about different planets that I was interested in. And in this line of work, you kind of need a PhD in order to get into positions where you're able to make those decisions rather than just being the person who's working on other people's projects. Not that that isn't exciting too, but I really wanted to kind of bring myself to that spot. And specifically, I got into several places, but at Arizona State, it was I had the opportunity to work with Dr. Jim Bell, who is the principal investigator on the MASTCAM-Z instrument, and I really wanted to be involved with this mission. The concept of sending something to another planet is really exciting, and the fact that you're constantly getting new data from that location while the rover is operating is really, really just cool. Every single thing you see is a new thing. And I
Mhm.
really wanted to be on the front line and actually be involved in that experience. So that's why I ended up deciding to come here. Right now I'm working more on remote remote sensing based research. So I'm like looking at orbital imagery. All of that is on the side. I've also been attending most of the meetings, and so a lot of what I do is also actually listening in on those and trying to understand the process better of how this mission even happens.
is it also the MASTCAM? Was it something similar to what Curiosity also had? Because that would snap pictures of, I think, color images of and video footage, take it in
Yeah.
panorama shots, and then stitch it all together.
Yes, it's analogous to that. It's sort of the eyes of the rover, basically. Um, I think what is different about it is that it has the capacity to zoom. I think that's what the Z stands for. But
Correct. Correct.
yeah.
And so when you have this such a big mission coming up, what was your first reaction when you knew that you were going to be involved with this particular Perseverance rover, and it's going to be a long journey, but something that's so exciting, and like you said, you've always been interested in this, and now to suddenly get the news that you were going to be part of this mission. What was your reaction, and how did you feel that day?
I was very excited. I wasn't like obviously I knew I was coming to school here, but I actually didn't expect to. I didn't know what to expect in terms of how great my involvement with the mission would be. Like I wasn't sure that if I would actually have access to all of the meetings and everything because you do have to get cleared through JPL and all of that. And I wasn't sure if as a first year student I would actually be like tossed into all of that or not. But when I found out that I actually was going to have the chance to do all of that, that was super exciting. And especially like what Dr. Bell and I have talked about the most is once images start coming down, there's the opportunity for people who are on the science team to actually start making interpretations based off of those and like try to understand the geology and then write it out in a way that everyone else who's on the team and even sometimes the public can understand. So I'm really looking forward to actually throwing myself into that aspect because I'm not as well versed in the whole image processing side or like the I guess the coding based parts of
Mm,
this
mm.
entire process. That's not really what my strength is, but uh the the actual opportunity to work with the data that's coming and specifically the visual data because it's MASTCAM-Z that I'm most involved with. I'm really excited about that a lot.
Would you be able to explain to us what is a day like for you working on this project? How do you start your day, and give us a little bit of insight into what you actually do, things that we could understand a little bit more, because it all sounds so alien for us. Sorry to use that term, but none of us are experts. And the moment we are NASA and the moment we are Mars, generally that's where our knowledge and information stops. So anything that you tell us is going to be really interesting.
Oh yeah, absolutely. So well, I mean, naturally because the pandemic is still happening, that there's aspects of my workday that aren't normal, in the sense that I don't keep to a specific schedule necessarily, but um, I think on most given days, what I tend to do is uh, oftentimes we have actual meetings that are team meetings, and so I tend to actually go to those meetings. They're usually an hour or so long, and they it depends on the kind of meeting, but some of them are more focused on actually like how the rover is, well, the spacecraft that the rover is in, how it is doing currently, and whether it's still on trajectory, and then sort of planning out all the tactical aspects of like how do you make it how do you make the first few days that the rover is on the surface run, in terms of the schedule, especially because you have to account for Mars's daylight and night time being much different from Earth's, and like there's also the lag time between communication from Mars to Earth to account for. So there's all of that, and then there's also been meetings where people have sort of focused on different parts of the crater and presented on those places in detail, because the Mars 2020 rover is going to Jezero Crater, and specifically to study the main western delta that is in it, but we don't know right now where exactly in the crater it will land. Like it could land on the delta itself, it could land just off of it, or it could actually land further away, like sort of towards the center of the crater instead of on the side. And so there's a lot of planning that the science team has to do about, well, how will we deal with all of these three, general scenarios? What would we want to focus on studying first? And you kind of have to plan out a traverse for the rover that, obviously once it lands, there's going to be differences from that trajectory, but at least to go in with some sort of concept. So I've been going to all of those meetings that talk about those sorts of things, and those tend to happen at least, twice a week. So um, I'm often busy with that. And then in addition to that, what I'm personally doing right now is actually a mapping project primarily. Um, I've been using imagery from the Highrise camera, which is on MRO, and it's orbiting. And the cool thing about Highrise imagery is that its resolution is like 25 centimeters per pixel, roughly. So that means that if you can imagine that, that sort of means that from the satellite image, if there was a picnic table on the surface of Mars, you would be able to see that. So that's kind of the
Wow.
level of detail that there is there. So it's really, really nice imagery, and it's all in black and white. But what I'm trying to do is trying to find different units. I'm focusing actually on the northern delta. So I was talking earlier about the main western delta that the mission is focused on, but there's a smaller northern fan deposit, and we don't entirely know at the moment whether it is just an outer remnant of the western delta or if it has a different source, because there is also a channel that's at the northern part of the crater. So what I'm doing is I'm at this very detailed mapping scale, I am trying to find different geologic units. So I mean, the very simplistic way of understanding that is kind of like if you're looking at a satellite image of Hawaii and you're trying to break it out a bit, you would say, oh, this is like the big black area that's covered with all the basaltic flows from the volcano. So this is all one unit. And then you'd see all the sandy beach and be like, oh, this, is clearly another different thing. And so I'm going to classify that as a sand sediment unit. And basically it's like that at a much more complicated scale, because there's a lot more that's going on in this specific area. But so that it's mostly me drawing. I
Yeah.
joke about this a lot. I spend a lot of time just drawing things in ArcMap, because that's the software that I use. It's by
Mm.
Esri, and I've gotten very good at drawing circles, lines, polygons, yeah, you name it. I'm very good at drawing things now. That's not that's not actually all that I do, but I I joke about that.
And you also spoke about the high-rise photography or the high-rise camera. Can you explain a little bit more about that?
Yeah, it's on board the Mars Reconnaissance Orbiter. That instrument has been taking imagery for a while now. So that there's a pretty good coverage of the Martian surface. I don't know what the exact percentage is, but it's there's a lot of the surface that we have at that high resolution. Not everything, but
Can you tell us a little bit more about the landing site of the crater you were just talking about? Because I wasn't aware of it, or maybe I don't know how many people would be aware of it, that we would try to figure out what would be the perfect angle or location for it to land, and then what would be the worst.
um, well, there's some debate about that because it does depend on what people's priorities are, to an extent, like what different scientists find most interesting about the area. Uh, I think that the ideal situation would probably be like just off of the delta, but not so far away from it that you have to spend a lot of time driving to even get to the delta, because that's the challenge, is that these rovers, they're the size of SUVs, but they don't move very fast. So
Hmm.
so if you have to traverse a lot of distance to even get to the main focus, then that's kind of a challenge, as especially when in the beginning you don't know how long the rover will last and all of that. And obviously we've had really amazing stories with Opportunity and Curiosity and stuff of like how resilient these missions are, and so I would expect Perseverance to be that way as well. But still, it's probably best for it to be like just off of it, but not on the delta, but also not very far away. I think being on the delta is better than being very far away, but the best thing would be just off of it, because I mean, in geology, one of the best things is this idea of stratigraphy, that the oldest layers tend to be at the bottom, and like generally speaking, and then the youngest material is what is at the top. So the idea would be, then, if we were able to be at the bottom of the delta, then we would be able to sample the oldest material and then keep driving sort of up the delta and be able to explore different units as you went up, because they're all kind of in a stack generally. So
Staying to your area, that you were talking about the geology part of it. What could you tell us, or everybody who's listening here, about Mars and how different, or what do we know about the surface there currently from what we knew a few years ago? And what strikes you the most, or what do you find most interesting about how different it is from Earth, or how similar it is?
yeah, I mean, I think it's kind of interesting, because there's the popular idea in science that at some time Mars was like Earth, actually. So I mean, not exactly the same, and we don't know about whether there was life or not, obviously, right now. But um just a warmer, wetter place, at some point. That is the current thought. And there's plenty of evidence that it was a lot more wet before, because of all these deltas and channels and everything that you can still see the remnants of on Mars. So, um, it's such a big mystery. Like, what happened? Obviously, we have a lot of theories about what happened, but like, it's the same reason why Venus is interesting to me, is like it's kind of an example in the other direction of like, it's the same size and all, but it's such a drastically different environment there. So I think one of the coolest things about studying different planets is getting exposure to all these different environments. On Mars, especially, like, the at this point the atmosphere is very thin, and because of that, and that it's not really protected by a magnetic field the way that at least not at nearly as intense as Earth's, which is part of the reason why the solar wind has been able to strip away Mars's atmosphere. But um the effects of that on the surface are very interesting because almost everything is covered by this layer of dust, and Mars has these huge dust storms that just sometimes cover the whole planet in dust. But it's not like in the Martian, where it, like they show it as being very intense and all of that. Like, if you're actually on Mars, you wouldn't really get knocked over. That wouldn't be the issue, really. It would be the fact that the dust would get into everything. That would be the biggest danger. I don't personally like study the subsurface that much. But I mean, a cool thing about the Perseverance, actually, that is different from every other rover that has gone to Mars, because some people might be like, why do we keep sending things here, when there's all these other planets? But it's cool because Perseverance has the ability to collect samples, and that's kind of the most notable thing about it compared to the other missions, is that it's going to be collecting samples, and we haven't completely decided yet about, are we going to keep collecting them and then deposit them in one place for a future mission to come pick them up, or are we going to, kind of drop them in sets of 3 or something as we go up? Or that they haven't completely worked that out yet. That's another decision we have to make on the team, I guess. But uh you talking about subsurface things made me think of that, because that would actually, eventually the plan is to bring those samples back to Earth, and that would be really amazing to actually get this material that isn't just on the top and what we can see from like orbit and all of that, but like to try to get a little bit of an inkling about how are these layers actually interacting underneath the surface.
Mhm, mhm. Oh, that would be super cool if you could actually get those samples back. But that, I think, like you said, that is the reason why Perseverance is so pioneering in that sense. One is it is part of a mission where rock samples are going to be collected, but Perseverance is also probably the flagship for preparing for life on Mars, preparing or checking, because you also are. We'll come to the helicopter a little bit later, but you also have another exercise going on, that is the MOXIE one, which is actually going to be testing changing or converting carbon dioxide into oxygen, because if you have to get those samples back, then you need to burn some oxygen to bring a spaceship back, right? So MOXIE is it's a part of this long thread, I guess. First of all, let's start with the broader question. Do you think that there is life out there? Because if you're into space exploration and you are on one planet already, you're in a spaceship, literally, right? Every uh, twice a week, you're in a spaceship for an hour. You're lucky. But what are your views on, let us say, life? I'm not even talking about intelligent life as yet on another planet.
I think there has to be life somewhere in space. I mean, you mentioned contact, and there's that whole line in there that's about, like, what, that would be such a waste of space otherwise, if there wasn't anything else. But I mean, I love sci-fi a lot, but I I don't necessarily know about whether there's sentient life or not, but I do think that it seems likely that there has to be some sort of life somewhere. I mean, it's probably going to be microbial if we ever find it. I do think it has to exist. I don't know about specifically on Mars, but I do think there's a chance that there could be microbial life within our solar system. On these icy worlds like Europa or something. On Earth we would use a biological explanation for. So it's it's definitely not something to rule out entirely, but also not something to blindly believe either.
Now, if we ever had to go to Mars, which I, I think is going to happen, do you think that somewhere down the future we need to start planning to have a Martian colony? And what are your views on what that is going to be like?
I mean I do think that eventually humans will definitely go to Mars. I don't think it's gonna be for a bit. Some people were saying that it would happen by 2030 or something like that, and I don't think so. Uh, just by the timeline that we currently have, I don't think that, because there's just so much we don't know about how humans will react to that environment, and there's also like I think we need to advance technologically to like be able to actually sustain people on another planet like that for a long period of time. Like it's different to send someone to the moon because that's like 3 days away, but if something goes wrong 9 months away, like there's nothing for it. As much as again the
Mm.
Martian does deal with that situation, but as for actually colonizing, I mean, I personally don't like the concept of actually colonizing another planet, but that's because I my first love is earth science, and I am passionate about the idea that, we do need to take care of our own planet. Like, I think it is important to obviously be exploring and studying other places, but I worry that if there was this push for colonization, then sort of the same uh, corporate issues that we see on Earth would just be carried over to another place, and like I don't know if that would be a good thing necessarily.
Mm. Mm.
So but like but like for if it's just like a small scale thing, like, oh, we're establishing like a research base, like some sorry, like many decades in the future, if we're
Mm.
just establishing some sort of research base on Mars that, like, some scientists live in, kind of like at the ISS or something. I think that could be cool. Uh, I don't know how that would work. Again, I think we need a lot more advancement in technology to make something like that possible, and that we should
Mm.
probably try that out on the moon first. But uh, that could be really helpful, because the problem is that, like, as amazing as rovers are, they still can't compete with like having an actual human geologist there. There's just so much that an actual person who is on the planet can notice and like connect, and also, why we want samples on Earth is that there's so many more analyses that we can do, because every rover sort of has a budget about like how many instruments it can carry on it, and like there's always conflict about which instrument should be used at which time and all of that. And then you can alleviate some of that if you have that material on Earth, but you could also alleviate that obviously if there were actually people on Mars, because multiple people could be doing many things at the same time. So I think that would be helpful. I do still think it's a future thing, though. Um,
The issue also about I mean, not the issue, but I think one of the aspects we would have to look into would be the concept of terraforming, and that seems to be catching a lot of people's imaginations. What are your views on that?
I I don't think it's certainly not possible with anything that we currently have. I think it would be very challenging to terraform Mars because it has such a thin atmosphere that, and we don't really have a mechanism of like we don't have any way right now to be like, oh, like if we tried to pump oxygen in or something, I don't know how you would go about it exactly.
True. You were part of the Mars 2020 science team as well. So tell us something about that particular activity and what you do in that field.
Yeah, so it's kind of challenging right now because I mean, a lot of these things, if the world was normal right now, like, I might have actually had the opportunity to go, and how they show in movies like Mission Control and all of that, like, or like even when the launch was happening, I might have had the actual chance to go to Florida to watch it and all of that, but like it that's kind of the part of the student experience that is usually exciting, is like, actually being on the floor with these big people and having this easy ability to like talk to them and all of that. And I think I am feeling that loss to a degree. Even though I'm obviously, doing my best and all of that, it is kind of isolating right now. But at school, with school itself, also, my classes are all virtual, but there's other people in my lab group who are also on the team. So it's been nice that I've been able to at least bond with them to a greater degree, because we have weekly calls and stuff where we talk about our progress. And um, I'm also able to go into meetings with, people who are based at ASU who are actually working on the MASTCAM-Z instrument, and then, like I mentioned, the science team meetings where they are talking more about like what direction should we even send the rover in and all of that. These are all different, basically like Zoom and WebEx calls. So uh, I definitely learn a lot from them. So that's good. And then they have been making an attempt using virtual platforms for like more social events so that we can at least try to get to know each other more.
I'm sure this is also one of the first launches of such a major launch that is happening within this virtual bubble, right? Any launch of this scale in the past would have always had interaction because it's so important, like you said, cross-functional interaction. But here, everything has to be done virtually. So that's the first of its kind as well, for teams to be interacting virtually for such a big launch.
Yeah, yeah, absolutely. I mean, it's unprecedented. All the A lot of videos that NASA publishes about Perseverance now mentions how like apt that name feels in light of all of this, because everyone in the team is showing that the ability to be resilient despite uh, these challenges.
Where are we getting it wrong, or what should we be doing? Yes, we're on our way to Mars, Mohini, and I think that seems to be the future. But we should not let go of our present, or rather, where we came from, right? The mothership is right here. And what do you think we should be doing more?
Uh, well, I think there's a very long list, but
Your top three.
I I guess like I think something that bothers me is that there's a lot of discourse about like at the individual level of like recycling and all of that, and like those are, obviously I'm not saying that everything that one person does can't help, but uh I wish that there was more regulation on corporations and these like big companies that are doing things like releasing gases into the air and like dumping trash into the oceans and all of that, because like that is adding to the problem at such a larger scale than whether I recycle one glass bottle or not. And that's not to say that every little bit doesn't help, but uh I think that there's just such a prioritization of like financial gain over the welfare of the planet, and so that philosophy is what really needs to change. But I don't think anyone is really going to acknowledge that until things really start getting bad on Earth in terms of these natural disasters. I mean, in this past year, obviously it was all overshadowed by the pandemic, but the wildfires that were happening in Australia, and then the ones that happened in California as well, that those were really striking, very bad, and very unprecedented. But and then just the warming temperatures on Earth are also unprecedented. But it just feels like most people who are actually capable of making changes that would actually help with all of this aren't interested in doing that right now. So uh that's concerning.
If you were a decision maker and you could take a decision, what three decisions would you take to make things better?
I would definitely try to, I think reducing like air pollution is probably a big one. There's probably several ways you could go about doing that, but like that's kind of a major category. And then also not like polluting the water with like factory waste, but also just like our trash from our landfills and all of that. And then probably like trying to find something sustainable that was a cleaner energy source. Like down here in Phoenix, it's nice because it's sunny a lot of the time. So like I think if Phoenix really did try to become fully solar dependent, that would be really cool, because that is an asset that we have here, that a lot of places in the world don't have. But I think it is possible. It's just that it's this concept of like, are you willing to put in a lot of money in the beginning for a good payoff, or are you so obsessed with like saving every penny that you're going with the cheapest option that is very destructive in the long term? And so if I was in charge, I think I would try to, it would be hard to convince people, but I think I would try to make these decisions that, may not be financially the best in the beginning, but if you have the vision to like see how they would progress, then they would actually make things a lot better.
We will keep this recording as a charter to remind you that this is what you had committed to before you were in charge. So see that you don't change when you are in charge.
Oh dear. That's a lot of pressure.
Yeah, because yeah, and and as well. So Mohini, what else do you do now? You've got a fascinating job currently. Your interest, your enthusiasm towards what you're doing is really visible, and I'm really happy that you've gone into a field that you enjoy. that's the most important thing. But besides your work and besides you doing, besides you helping send space rovers to Mars, what else are you doing?
Yeah, well, I have a few hobbies that I like to do. I I've been interested in music for a long time. Actually, because of my father, especially, who grew up in India. But he's kind of amazing, because he's taught himself like six different classical instruments that are just like
Wow.
he's just like self. Well, he took lessons for tabla, but everything else, it's sort of, he just figured it out. And I guess I've sort of taken that spirit from him, because I was taking lessons for piano for a long time, but pianos aren't very portable. So once I wasn't in a place where I had a piano, it was kind of hard to keep up that, even though I would say that's the instrument I'm most passionate about still, probably. I just don't get the chance to play it very often because I don't have one. But I have the guitar, and then in like quarantine, I've been teaching myself how to play the ukulele, so that's been fun too. And then also I used to play the flute for a little bit, and now I've been like experimenting with the ocarina, which is another woodwind instrument.
Mhm.
So I like that a lot. I like singing a lot, also. So especially the things like the piano and the guitar and the ukulele are fun because I can do both at the same time. And then I've always loved to read a lot. Ironically, fantasy is my favorite genre, not science fiction, but
Okay.
I like magic a lot. So that's fun. And then I also like to write, actually. So I've written several poems, but also like short stories, and like I'm working on a novel too, but I've been working on it since I was 16. So
You're busy sending a spaceship to Mars, so I can imagine why you're delayed. That's not what that's not what most of us can say, because I've been writing as well, and I'm not sending any spaceships. It's been 15 years.
yeah, and then I have, I mean, one thing, because I'm an earth scientist, I love I love being on Earth, obviously. I think it's the prettiest planet. It's the only one that has trees and rivers like this, so there's nothing like that. So I like to be outside. I mean, I haven't, again, had as much of a chance to do that recently, but uh when I do get to go outside, I like to take nature photography a lot. I mean, I'm not any professional with like a DSLR or something, but I I've been interested in that for a long time, just like trying to find good shots to take. And one thing I do when these meetings get boring is that, well, not boring, but like long, uh, because of more of the technical aspects. I like to knit, so I
That's interesting.
yeah, it's a good way to keep my hands busy, I guess, when
Yeah.
things are
Bernie Sanders would be happy to know that.
yeah. So yeah, there's a lot of ways that I try to keep my mind busy, because the thing is that, as much as I love science, and I think it's beautiful and all of that, sometimes the entire like technical aspect of that can get overwhelming. So I think it's really important to have a balance between science and art in your life, and like art and like communication. I think a lot of times there's people who are like very high up in science who get very tunnel vision about their field, and and they're experts, and that's amazing, and like that level of intelligence is great, but then you don't want to lose sight of your ability to actually like be able to communicate with other people, because I think a lot of I think one of the biggest challenges in society right now is that there is a lot of distrust of science, and it's because scientists aren't always the best at communicating science, and so politicians are able to twist it. And so if scientists made that more of a priority, I think that there would be a better way to have a relationship to the public. And then art is just good because it stretches your brain in a different way, and then you can look. I mean, I'm making maps right now, and I think about color scheme and stuff like that when I'm mapping too, and I'm drawing, like I said. So I think it's important to keep sight of both things rather than just
And you brought up a very interesting point when you said science communicator, because I think that's an area that is lacking at the moment. There are very few and far in between that. I mean, Neil deGrasse Tyson, for example, is a great example of what you just said. Somebody
yeah.
who's an expert, but he's a great science communicator as well. And unfortunately, that's where people like me, who have absolutely no background in science, step in and try to put pieces together and stitch things together. But it may not always be the right way. I think you would be a great science communicator. And if people in the field start thinking of that as an actual vocation or a field that you want to get into, I think that would be amazing, because ultimately any science that is being done for the people. So having 95 to 99% of the people out of the whole thinking and understanding part of it, is it this doesn't sit, because we really know what the scientists are thinking about.
No, I absolutely agree with you about that. I think it's very important, and I'm hoping that as I progress on this track, I'm able to keep sight of that, especially because like when I started in my path into science, I wanted to be an educator, and so even if I don't necessarily end up being the high school teacher that I thought I was gonna be when I was in 12th grade, I still want to keep sight of that and hold on to that when I talk to people about what I'm doing, because I think that's really important.
Mm.
And I don't think, I mean, especially when I was working at the USGS, we actually had the opportunity, like I had the opportunity to actually volunteer with some of the science outreach events that they would do for the public, at science fairs or things like that. And there's just nothing like that, seeing that spark, when something clicks in someone's mind, and then they're just as excited about space as you are because finally, like, the
Mm.
dots have connected in their brain. Like, I don't know, it's just such an exhilarating feeling to be the one, or the be the one who's like showing off different planets, and then some kid is like, oh wow, that's so cool. Like, yeah, I don't know, I just really love being in that position a lot, because this is obviously something I'm very passionate about, and I think it's something that's super cool for everyone to be passionate about, because we're just on Earth. We're on this, Earth is an amazing place, but we're on this tiny dot. And there's so much more out there. And I think like this drive for exploration is part of what makes us human. So like it's really cool to be able to tap into that.
Today, have you ever thought of doing a science podcast? You could do one with the access that you have and the information that you had. We'll tune in and listen to you. All you need to do is take a mic and record and put it out there. Choose your topics. You should think about it.
That's actually a interesting thought. I mean, I've never thought of that. The thing is that I don't know. I've never really like thought of myself as a good. public speaker, like generally speaking. So like I think I've grown in that strength since I've been having to talk about my research in like at conferences and things. But that is a, I guess I'll have to think about that.
Mohini, have you ever been to India, or do you get a chance to come back here? You said your parents are from India.
Yeah, they were both born in India, in Nagpur actually, um, in India. So Maharashtra represent. I've been to India several times. We tend to go every like 3 or 4 years roughly. So I've had the chance to be there. Um, Obviously I enjoy it a lot every single time I go. I think I appreciate it more every single time I go. So that's really nice that I have the chance to connect physically with there. And I also I mean my parents actually like growing up I actually learned Marathi and Hindi and stuff. So that's really I mean I can't read and write, but I can speak and understand, which is really nice because I know a lot of other people who are second generation here who feel bad that their parents didn't take that time, because then they find it really difficult when they're in India to actually like engage in a meaningful way to the same level you could when if you didn't actually speak and understand. So yeah, that's really important to me.
If we had to wind this down, Mohini, and I would have to ask you about a message that you had to send out to everybody listening, to kids who are, I mean, you can think about it when you were looking up at the sky, and there are going to be kids now listening to you, where you are the inspiration, and thinking about your journey, and you sitting down there and attending all these meetings, being involved in this big mission to Mars. What would your message to them be? How would you inspire them, or what would you want to tell them?
I think the most important thing, honestly, is to find something that you're passionate about and that excites you. I think you should never like kind of box yourself into a position or you're stuck doing something that you're not interested in. And sometimes the way to get to that position isn't the most intuitive one. Like, uh, sometimes you might have an idea that, oh, this is how my life should be. This is exactly what I want. And these are all the boxes that I need to check off to get to that spot. And once I get to that spot, I'll be happy or whatever. But what I've really found along this journey is that if you like aren't open to other possibilities at all, you kind of destroy the opportunities that you could have in your life. You kind of destroy the ability for spontaneity to happen. And honestly, some of the best things that have happened in my life, and I am not saying this in just like an idealistic way, I mean actually like some of the best things for my career too that have happened in my life have come about in entirely unexpected ways. And so I guess what I'd say is like, and this is a thing I say often, is that treat life, but even in all aspects of life, but like right now we're talking specifically about more career oriented things. So even that, treat it as more of an outline, because like when you're writing an essay, you sort of start with an outline that and then you build an essay off of that. Let the essay happen as you live life. Don't be the person who goes into everything with the essay written, because you're gonna miss out on so much that's amazing if you do that. And I think like there's so much more to experience in the world, and it's wonderful to have the chance to do that. And just don't just write your outline and hold on to that outline and be extremely passionate about that outline. Don't let any minor setbacks along that break your resolve to keep going. But also be open for some things to not go exactly the same way, and for them to unexpectedly turn out to be even better than they might have otherwise.
And since you are also very passionate about earth sciences, as students listening to you choose careers and make those individual choices to get ahead, either in the corporate world or do meaningful stuff, what would your message to them be as far as the planet is concerned and choices they make? How should they balance, and what would you tell them are important things to remember?
Well, I like there's this idea that we're stewards of Earth in a way. I mean, this is a planet that we've been all born onto, and it sustains us. And, especially when you're in planetary science and coming at it from this perspective of Earth science, you realize that, wow, there are so many amazing things in the universe. But, this is kind of, in a way, the biggest miracle of all, that there is such a capacity for like society and all of that is here. And so I think people, as they're advancing and all of that, like, it's great to get ahead and become very successful and all of that, but this planet is quite literally our roots, and so I don't think we should stray so far from our roots that we lose sight of what is important. And that what is important is keeping this place as a place for all of us, but also for everything in the future, because it's not just about humans, it's also about all the plants and animals and everything that makes this planet diverse. It's all worthy of being treasured, because it is, as far as we know, the only place where it exists. So yeah, I think that's what I would urge people to keep in mind.
And Mohini, it's been an absolute pleasure talking to you. We listened to all your very exciting stories. I just hope we can do this again. And if you can ever come back and talk to us, I just hope that you've spent your time well. I know we did not get time to do this or plan this. So I guess the best part about it, it was very natural. And I think that shows, right? I hope you had a good time.
No, I enjoyed this a lot. It was really great. And yeah, for sure. If there's any opportunities in the future, stay in touch. This was great.
Piyush, a very big welcome to you from everyone here at Indian Genes. We are really excited to be talking to you. This is part of an ongoing series. As you are aware, we've been speaking to pioneers, legends of the past, people who've been paving the way into space. And I think you form that part of the journey moving forward as the next generation of thinkers, scientists, people who are actually going to be doing stuff. So it's an absolute pleasure to have you on the show, Piyush.
Thank you so much, Joaquin, for having me here on this podcast. I'm actually really looking forward to have a fun conversation with you. So yeah, thank you so much for having me here.
Perfect. It's definitely our pleasure. And for everybody listening, Piyush, why don't we get straight into it and give us a little bit of your background, why you are doing what you're doing, what you actually are doing, and finally, how did all this start for you?
Sure. So I grew up, I did all of my education up until my bachelor's in a city named Ujjain in Madhya Pradesh state of India. So I think when I was a kid, I was very fascinated about space. We have an observatory there, a planetarium in our city, and my dad used to take me for night sky watching. He would also educate me about space, and I think over the period of time, my interest slowly started growing. As I started reading more about it. Then in my school days, I again like started developing interest towards research. I started reading about spacecraft, like different space missions, like how their instrument work. So I also took part in like a couple of events organized by NASA. So I took part in like few competitions. There was an event called NASA Student Involvement Program, NSIP. So I took part in that with the help of my teachers. One of my teachers in school, like she guided me, and we did a small project on conservation, and we sent the report to NASA. And the cool part of that project was like, I'm like, we didn't really win anything, but we actually got that participation certificate. We had like the NASA logo and had the administrator, Sean O'Keefe, signature on it. And I think it was really motivating and inspiring for me. This was also like during the time of 2005 when the twin Mars exploration rovers landed. They also like did a program called Send in Your Rock. So and the idea for that was, so the Mars exploration rovers, they actually, it has a tool, a rock grinding tool. And what it does is it would grind the rock, and it had a spectrometer at the front of the arm, and it would take the spectra of the rock. So similarly, and that tool was, I think, provided by Arizona State University. The PI was in Arizona State University. So they actually did a very cool engagement program for, I think, for everyone. So what they did was they had a program where they asked everyone from around the world to send a rock sample, like literally a rock sample. And then they had a twin kind of copy of that instrument here on Earth in their lab, and they would take the spectra of that rock and they would put it. And their idea was to create a spectral, like a rock library. I found that very interesting, and I had a rock sample. It was mica, rock of mica. So I took like the smallest piece I could send because postage was also costly. So I sent a smallest piece of rock, uh, posted it, and after a few days, after I think few months, I got a very cool certificate saying that I participated in this, and that rock is still available on their website. So they can like, I can still go and look at my name, and the entire spectrum of that rock is available. I entered into college, my bachelor's, and I started giving presentations on like Mars exploration rovers because I was like very excited about that. Then I came here, like in the US for my master's, and there was this program called Solar System Ambassadors. It's run by NASA JPL. I applied for that and I got selected, and it's a very cool program where I get to like meet people. I get to talk to them, and I get to share excitement of like different NASA missions with them. Again, during this time, there is a society called Mars Society, and I attended one of the conventions here in the Washington DC, and that's where I met Dr. Michael Hecht. And then I attended the talk. I actually found like that's very interesting. So I wrote to him, asking like, hey, look, like I'm really passionate about this field, and if there's any way I can help, I can contribute. And he was, I think, very kind enough, and he might have like saw my passion as well. So he was very kind enough, and he replied and saying, "Yeah, sure, let's meet." And I met with him, and then that's how my journey got started in the MOXIE project. Here I am today, working with them, and very excited about the landing on February 18th.
Brilliant, brilliant. That shows a lot of perseverance. And interestingly, you mentioned initially when you had to send certain rock samples because of the contest that you wanted to join, you had to actually take the trouble of get a rock sample, post it, send it via post. I think that is so interesting. And when did you move to the United States, and which part of the United States did you move to, and which university were you studying in?
Yeah, so I came here for my master's in 2011, in fall of 2011, and joined the University of Missouri, near Chicago, basically.
Getting to the MOXIE mission, a lot of our listeners want to know. So, what tell us and give us a breakdown, one, on the instrument that you're working on or you're part of the research, and development, I would say, once this is launched. But tell us a little bit more about MOXIE so that we understand what we're talking about.
Sure. So MOXIE is one of the instruments about the Mars 2020 Perseverance rover. One of the goals of the Mars 2020 rover is to prepare for human exploration. And when humans are on Mars, then while coming back, right, it's not going to be a one-way trip. It's going to be two-way, of course. So you need basically fuel for coming back, and you need when you burn fuel, you actually need oxidizer because that's how you burn the fuel. You basically need oxygen, right? So MOXIE basically stands for Mars Oxygen ISRU Experiment. ISRU stands for In Situ Resource Utilization, which basically means you generating a product with the help of local resources. So MOXIE is a technology demonstration for producing oxygen on Mars. So Mars has a lot of carbon dioxide in its atmosphere, and that's what MOXIE is going to demonstrate, that it's going to produce carbon dioxide present in the Martian atmosphere into oxygen.
This particular instrument, it's going to be used for the first time. So it's kind of a test experiment. How big is it, and where on the rover is it located?
It's the size of a car-sized battery. I think from a rover perspective, it's on the right side of the rover.
What is the timeline like? When are we expecting MOXIE to wake up, start doing what it's doing, and what exactly is it going to be doing?
Yeah, so for that, that's a good question. So you basically like make sure first that the instruments are okay, if they're healthy, if they actually if they're still kind of alive after the landing, because as you might have seen, like when the spacecraft actually like lands, it's terrifying 7 minutes, and a lot happens in that. So we actually first want to make sure that the instrument is healthy. Once we do that, then we you start like incrementally, because you are actually sending this instrument on a complete like on a different planet, and you just don't want to rush in doing things. So we would want to like go incrementally. So we would first do like some health checks. We'll make sure that the MOXIE is actually healthy.
What we are saying here is that this particular instrument is going to be using carbon dioxide, which is in abundance on Mars, and convert that carbon dioxide into oxygen. And at the moment, just show us that that is possible. We are not talking about volume at the moment.
Right. So so carbon dioxide is almost like 96 to 97% in the Martian atmosphere. So what we do is we basically separate the one oxygen atom from carbon dioxide. So that produces O and CO. Okay. So it's like a fuel cell. So what you generally do in a fuel cell is so most people are familiar with the hydrogen fuel cell, where you put hydrogen in, you put oxygen in, and you get out water. Now what happens is MOXIE is just the reverse of this carbon-based fuel cell. What you do is you put in electricity, you put in carbon dioxide, CO2, and then in return you get CO and O. So that's how it's going to work. So what happens is we first pull in the Martian atmosphere, and through filter, we filter the Martian carbon, like the atmosphere, because the atmosphere contains other gases and dust particles as well. And we are more importantly, we are filtering the dust particles before it moves forward in the process, because we just want to avoid any physical damage to the instrument. After you suck the Martian carbon dioxide, we pressurize it, and then we actually pass that gas, the carbon dioxide, to a special ceramic. It's kind of a cell, okay, like a stack. And then where we like using electrochemically, we actually split that carbon dioxide into O2. Now for doing that, that ceramic I mentioned, it actually needs to be heated at 800 degrees Celsius. And at the end, we have sensors which actually measures the oxygen purity, the production rate and purity. And that's it. We are not storing the produced oxygen at this moment. We just, after measuring the production rate, the purity, we actually just like exhale that out in the atmosphere.
Very interesting. And Piyush, if you could tell us a little bit more, or try to cover a little bit more of your activities on ground since you've been involved in this MOXIE mission?
My involvement is more of like out of passion. So it's not my full-time job in Moxie. So what I do is I'm actually part of the software team at MIT. I help develop tools for data analysis because once we get the data, like that's the main important thing. We need to know if actually we got the data as expected, and that's where we need data analysis. So I'm part of that software team. I am also going to be part of the operations team for Moxie. So in operations team, you actually send commands, and when the data comes back, you actually analyze it and make like inferences from the data. And then based on the data, you decide like, as I mentioned earlier, like whether Moxie is healthy or if the data you got is the expected data or not. So that's actually like my overall involvement.
So, Piyush, during this particular mission or build up to this mission, as you said, you are going to be collecting and analyzing data. I'll come back to that on how that is going to happen in real time. What else
Mhm.
is your involvement with this mission or helping people either get accustomed to it, spreading information? Uh, what else are you doing?
Yeah, so I think that's a really good question because I'm actually part of the this program called Solar System Ambassadors Program. It's run by NASA JPL. I give presentations, I give lectures and talks, and on how on the Mars Returnative mission MOXIE, not specific to this, but even like other NASA missions, just to spread the awareness and to and the main reason of spreading the awareness is to inspire the young kids who are basically the future.
One is you are working on data that's coming in from Mars at the moment or as it comes in. The other one, as you mentioned, you are I could use the word science communicator as well, where you are breaking down this information to students and involved with NASA and JPL, which is very interesting to hear. Now, to get back to your live data, you mentioned it or you said there were two parts to it when you start getting this data from Moxie. You spoke about a command and then you spoke about receiving data. So, if I
Mhm.
could just try to understand that, when you say command, are you saying that there are some commands or there's some information that you are passing on to the Perseverance while it is on Mars? First of all, let me just try to understand that.
Yes, that's right. So what happens is like rover is on Mars, right? So the way operations work of a rover, not just for Perseverance, even for Curiosity, what happens is you actually send some sequence of commands, or commands as in like let's say you are like the rover is on some certain location, then you actually send some sequence of commands saying that go look at this rock, or like drive forward, or like drive this like this much meters, or so like for Moxie it's going to be like for Moxie you really like we are not driving. I mean like we don't need to drive rover for Moxie because we are not actually taking pictures, right? So for commands in respect of Moxie, it's going to be that when we decided that like tomorrow is the day, and again like a day on Mars is called a SOL. So let's say if we decided that like tomorrow's is the soul, we are going to run Moxie. So the command would be like to run Moxie, like start Moxie. It's so much time, or basically like run Moxie.
Interesting. So,
And
whatever, go ahead.
yeah, and sending commands is like uplink. When not is like it's called as uplink, that you are uplinking something, and then when you are getting something back, it's called downlink because you are downloading the data. You're getting the data back from a spacecraft.
Very interesting. And I just want to stay with Uplink at the moment. So, what is the platform or what is the method and how do you send this message for somebody like me who knows nothing about technology? Are you sending it in codes? Are you sending it in bits? Is it a specific or unique way of communication? How are you communicating?
Yeah, so like the sequence is like it's a numbers of zeros and one, right? That's how you send the command. So you basically like in human readable language, you actually like formalize things, and then there is a system which actually process that commands and then convert that into zeros and ones. So what happens is like there are these big antennas, dish antennas, and uh, they like it's operated by NASA. It's called as Deep Space Network. So what happens is you actually like talk to the rover with the help of the Deep Space Network. You send that sequence to the rover via these dishes, the Deep Space Network. Did that
That's
answer?
interesting. Okay. And Piyush, has how do you test this on Earth before it's gone? How are you test? How did you all test your communication systems?
Yeah, that's a really good question. What we do is like once we have some set of commands, we actually try it on the software model. We get the data, and then we make sure, we then analyze the data that whatever we are expecting, are we getting that result back from running those set of instruments, like from set of commands from the software models. After we do that, then we actually have an engineering model. It's called as the EM model. It's kind of a replica of the actual like flight model, which is on Mars. So once we are okay with the software data, like data from the software model, we actually run the same set of instructions on the engineering model. Then we get the data and then we analyze it. And then once we make sure that it is actually expected, I mean, like the data we are getting is what is expected. It's not breaking. Basically, like the main thing is like you should not be, you don't really like want to break that instrument. So once you make sure that like it's not breaking and we are getting the data we want, and for every like set of instrument, like they're like it's kind of an experiment. You're doing an experiment on some piece of hardware, and then for every experiment there has to be a goal, right? So you actually make sure that like whatever goal you want to do in some experiment, you are actually achieving that for that particular experiment. And once we make sure that everything we are getting from some like certain experiment, like the data seems good, then after that we actually pass the data and like we actually send the data to the actual rover, like actual MOXIE on Mars. So that's how the
Mm,
entire pipeline works. Yeah.
okay. And coming to downlink, you said when signals are received or signals
Hmm.
would be received from MOXIE, that those would be called downlink. And
Hmm.
that, I assume, comes to you or your team or the team that's managing this particular data. And you would then decode it and pass it on to people involved in the study.
Right. Yeah. So what we do is like once we get data from downlink, we process the data, and then after processing as in like make it like human readable, basically. And again, like that part is done by JPL. So as I mentioned, like the deep space network. So like the data comes in as zeros and one again. So the deep space network, or like there is a pipeline which actually process the data in between, and then we get the data, and then we then analyze the data and then make inferences out of it. And the science team of MOXIE, like that, they make inferences out of it. Like, yeah.
Okay. And for all this to happen, Piyush, how excited are you about this landing and what are you doing to follow this mission?
Yeah, I'm super excited about this because I have been all these like landings on I like for the Mars exploration rover. I watched it on TV. I was in India for the curiosity as well. I was here. I watched it on TV. Well, again, this time I'm just going to watch it online. But I'm very excited about this time in particular because this time actually I'm part of the mission. I'm actually like contributing. So it's very exciting for me. I mean, like when I honestly like think of it, I get goosebumps.
No, that's a brilliant story. And you said in 2004, you connected with the first mission, or the first mission at that time had an influence on you. How old were you in 2004? And do you remember what you were doing when you were actually following that mission here in India?
I was 16 because when I said I was in ninth or 10th standard, I believe. Yeah, and because I remember that exactly. Well, I should remember that because that's my age. But if the rock I'm talking about, right? So when I mentioned like you can still go and look for that rock. So it says my name, Piyush K, and age 16 and India. So that's how I remember. I'm not sure if they really aired the live broadcast of Mars Exploration Rover. I don't know because I did not watch it, I think. But what I remember is after I think few days, they actually aired a documentary on Netflix on National Geographic, and that actually like walked through like the entire I think like building of the rover, like how they build it, how they like what were the different steps involved in that building, or what were their challenges, and and that's how like I got connected with the mission. And then what I used to do is like for Mars exploration rover or even for Perseverance, like all the raw images are going to be on the NASA website, so anyone can go and get the raw images. And that's what they used to do. Like all the raw images come used to come on their website. So what I used to do, and like the way I used to connect to the mission, I connected with the mission is there were a lot of pictures in newspapers. So I made a journal for me. I used to take out like the pictures like from the newspaper, put it in the journal, and then every day I used to go to internet and then get the raw images, get it printed. I literally like used to print the images, put it in the journal, add some caption, just to make just to learn things like how really like Mars looks. So in every mission, what they do is you send in your name. So they put a chip, like a tiny chip on the rover. There was one for the Mars exploration rover. I couldn't do it for the Mars exploration rovers because I didn't know about that. But for Perseverance, they actually put a chip, and then everyone around the world can send, like, you just like type in your name and you just basically send your name to Mars. So that's how you are actually flying as well. I would actually like to mention one more like quick story from there. So there is also like a society called Planetary Society. So for Mars exploration rover, what they did was on the rover the rover actually had a sundial. On the sundial, there is a message, and that message was written in Morse code. Okay, on the edge circumference of the sundial. Now, what Planetary Society did was to just to for a student engagement to spread awareness. They actually did the competition to actually decode the message. Now, I did not win the competition, but I did decode the message. And it was very cool because I did not know about how to read the Morse code. So I learned the signs meant, and I decoded it, and I got a cool certificate of that as well. And the message was, "Wish you were here." So that's written on the sundial, circumference of the sundial, which is on the Mars exploration rovers.
Wow, this is absolutely stunning. I need to break this down. There's so much to
Yeah.
unpack in what you've just said. So, Piyush, when you were a 16-year-old kid in Ujjain in Madhya Pradesh in
Hmm.
2004, you have just told us that you downloaded pictures, you printed pictures, you put captions, and you made a journal. To me, those
Hmm.
are the fundamentals of a website, and that is what you did. You made a personal collector's items. You were doing all this because obviously internet and connectivity at that time would not have been as fast as it was today or as fluent as it is today. But that is so stunning that you would have started at that age. That's one. That's just a stunning story. Now, at that time, did you ever think, as a 16-year-old kid, were you ever apprehensive? Were you ever, or were you confident that one day I will be involved in a Mars mission? Did it ever cross your mind, or did you ever work to this as an end?
Yes. I am not going to say that I thought like one day I will, but my thinking was one day I want to. I want to, like really involved in an actual Mars mission. Yes, I did that.
Wow, that's such an inspiring story, Piyush, seriously. And the second part that you spoke about even more. So you learned Morse code, decoded the message that was sent up on that sundial just so that you could decode that message. How long did it take for you to learn this Morse code?
I think it took me like some time, maybe like few weeks. I mean, they had the guide and everything. You first like learn what a particular, let's say, dash line mean or a dot means, and then you basically like piece them together. they did provide a guide, which was kind of little helpful for me because it was like I was learning it from scratch. But that's how I learned it. Yeah,
Mm. And there are a lot of kids listening to you now, Piyush, 16-year-olds, I'm sure. There are college kids, there are university students who are just going to take so much of inspiration listening to you. But if you could tell me this interest, it wouldn't have started, or it wouldn't have just ignited at 16. What do you think in your environment, your family at that time, what inspired you towards this? Because the kind of passion and dedication you had to a subject, which could be Mars or space exploration in this case, was there something earlier that or around you that inspired you and motivated you, or got you going on this path?
I think I was always interested in, I think, space science, like learning more about it. I was curious from early age. My parents, I think they always supported me, because they never said that, oh, you are wasting your time. Because, like literally what I used to do is I would like just write, like type some letters, send it to NASA, and then they would send me like some like tangible like posters or lithographs or like booklets, and I would just read them. That's how I developed the interest. So I think overall, I think you are right. I mean, like I think the family and the relatives as well. So one of my uncles, I mean, like to be honest, like I did not know like what NASA was or what ISRO was like when I was like growing up. He actually like told me, hey, look, like this is the website of NASA, and he actually like showed me around, and then after that I started like exploring the website. I started like learning. It's not more about like you're just exploring the website, you're just like browsing the pages. It's more about like you try to read, or you try to find the thing which interests you the most, and then you read it. And then of course at the school, because the teachers have played a really important role. Because one another thing actually I did not mention, which is like completely related from the space journey, was I actually sent a letter to the President of India, Dr. Abdul Kalam, at that time, with an idea saying that can we make like electricity from vibrations. One of my uncles, one of my neighbors, we were just talking, and then we came up with this idea. I mean, like, and then we brainstormed it, and then we thought, okay, let's just send it over to him. Because Dr. Kalam, he was like very appreciative of like all the kids. Like he used to like inspire or motivate. He literally like he had like that time, like on the President of India website, he had a children's corner page where people would like children's would like kids would post their questions, and he would, I think, really answer them. So what I did was like I sent a letter to him. The only thing, I mean, like, well, that's a really biggest thing, because like the biggest thing was like he took time and he did reply to me. So I still have that letter. It's not signed by him, it's signed by like one of his I think the controller there. But he did send a letter to me. And that piece of paper, that letter, what he did was he actually sent my report. I actually sent like a small like report, like a page, a document, to him, asking like if that can be done. So he actually sent it to ISRO and DRDO for further investigation. That was really a big motivator for me, because when I got that letter, I got so motivated that I thought like, oh, I can do research. I can actually be involved in research, and that was another like a biggest push and a boost for me when I was in school.
Dr. Abdul Kalam has been an inspiration for all of us. He continues to. Everyone involved in, you used the word curiosity a little bit earlier. So I think, yes, every curious mind somehow seems to find another curious mind. So absolutely inspiring again from what I'm just hearing from you. And on those same lines, Piyush, now that you are in the US and working very closely on this particular Perseverance Rover, what are your thoughts on the future of the space program back home here in India? Now, we have ISRO that's very boldly doing things, and it has a great vision for moving into the future. I'm trying to understand from you, because this is what this whole the discussion also is, in line with whoever we've spoken to before, is what is the future now, and what is the future here in India, where individuals like you that have, through sheer perseverance, determination, of course, talent and skill and intelligence, reached where they are. Grit and determination, from collecting books and pictures to actually working on the mission in the US now. So, how does this, how do we circle back? And what do you have for India moving forward as far as space exploration is concerned? Where would you like to see this going? How would you like to be involved? What ideas do you have for us?
I think like looking at like all the space missions of ISRO, I think it's we are actually doing like a very tremendous job because we launched the Mars orbiter mission. We are working on the Chandrayaan, like the next Chandrayaan mission. So I think it's like very exciting. When you ask me like what I can do, I think I would be very grateful if I can contribute in like one of those missions. So when I mentioned like I used to like write to like NASA or so I did write to ISRO as well at the time, saying like, can you send me like some brochure or some book on the Chandrayaan mission? And I still remember the person's name. I think her name was Dr. Jayanti, and she actually sent me a book on Chandrayaan. I did read it, and so I think one way I would love to contribute, if I can, is to, of course, like really working on the like one of the future missions of ISRO. But at the same time, as I mentioned earlier, spreading knowledge is another big part of this field. So if I can in any way spread the knowledge, then I think I would love to connect. And I think with the Chandrayaan, I think the coolest thing I found was when they really did the live broadcast of the entire landing. When you really watch something like happening live, so I think if we look at that direction, I think we are actually really like doing great job because like inspiring the young kids in India as well to come into the space sector because space sector is challenging. It's a hard work. It requires, I mean, like I'm not saying like other fields does not require hard work, but it requires like a really lot of dedication. It requires hard work. And I think all these things when like combined, I think that is really inspiring and motivating the young kids in India to come be a part of the space missions in India as well. When you ask me like how I would like to contribute, I think in any capacity. I mean, like in any if I can get the chance to actually work on the mission, like on one of the ISRO's mission, I would be grateful for that. Another thing I or like anyone can contribute is to spread awareness, to talk to people, to inspire the kids because guidance is an important thing. And if you are like spreading awareness about these space missions, it's also you are guiding the kids to be part of this space organization.
The future of the Indian space mission or missions is going to be in the young hands and minds of people like you and your colleagues. How bold do you want us to be? When we talk about India, then future of space, is there a cap to this? Do you see that there is any limitation? Or how do you want us to move forward? If kids are listening to you, how would you inspire them to break boundaries?
Even if you fail, you learn. Like for different Mars missions, like an instance, a lot of Mars missions have failed in past. But the thing is, with the failing, is you actually like when you fail, you actually learn. I mean, like if you look at the ISRO, like with the Chandrayaan mission, that's how we are doing. We failed, but within like few months, we actually said that we are going to try again, and that actually shows that how bold we are and how bold we want to be moving down the line. So that's very encouraging, and I think, and yeah, I'm like that's very encouraging and that's very motivating.
I just have a question. You don't have to answer this, but given the opportunity, if there is an opportunity or a project is coming up, maybe there's no, or you already have set your mind that you want to be committed to space research in India, would you ever think of coming back to India now that you've settled in the United States? And I think you're well on your way to achieving a lot of future successes and professional accolades in the US.
Definitely, yeah. If given an opportunity, I think I would definitely like love to come back uh, and you know uh, do the work there. Yeah.
What would your message be, Piyush, to kids listening to you? What is your inspirational message to them?
If you're really passionate about something, you need to try hard. Because what I feel is like all you need to do is keep the ball rolling. You don't really need to do a long jump. What you need is a step, and all those small steps actually like lead to your passion. And but at the same time, it takes time. Other thing I would also want to add is like when I was in school, I was kind of an average student, but I think I always had the push within me to try things which I'm passionate about, and I never let that go. So that is something I would really like encourage kids, young kids, to try that.
Piyush, it's been an absolute pleasure talking to you. You are a real inspiration to all of us, and just listening to your story, I think a lot of us listening would agree with me that we have a bright future. Even if it's one kid somewhere listens to this, and okay, if Piyush could do this, and why not me? And in 10 years, that's the next kid that is changing or revolutionizing space. I think that would be so inspirational. So thank you once again, Piyush.
Yeah, thank you so much, looking for again like having me here. At the same time, I really want to like thank you for doing this work, because like spreading the awareness is an important thing. And again, like through this with the like through this podcast medium, as I said, like if I can inspire even a single kid, I think I would be very grateful.
इस हब हॉपर ओरिजिनल को सुनने के लिए आपका शुक्रिया। अगर आप भी अपना पॉडकास्ट लॉन्च करना चाहते हैं, तो हब हॉपर स्टूडियो वेबसाइट पे रजिस्टर करें और 1 मिनट के अंदर अंदर अपना खुद का पॉडकास्ट लॉन्च करें। यही नहीं, स्टूडियो देता है आपको पूरी आजादी कहीं भी कभी भी अपना पॉडकास्ट लॉन्च करने की, सिर्फ 3 आसान स्टेप्स में। तो साथ में अपना पॉडकास्ट शुरू करने के लिए तैयार? जस्ट हॉप ऑन हब हॉपर, सिंपली कंटेंट।